Hi, my name is Shivam Garg. I'm a fourth year PhD student at CSRC. Today I'll talk about a quality of service aware routing protocol for airborne wireless networks. My advisors are Dr. Sunil Kumar and Dr. Alexander Eiler. This project is funded by US Air Force Research Laboratory. Airborne networks are dense, self-configurable, multi-hop, decentralized, and highly mobile networks. They must satisfy the dynamic quality of service requirements of multiple flows. This includes priority-aware communication, in-time delivery, and high flow throughput. The main challenges of airborne networks are as follows. The nodes are highly mobile. This results in frequent link breaks, which causes packet drop. Frequent link breaks require frequent route selection. This has high route switching cost because the source node has to retransmit all the dropped packets again on a new route. Airborne networks are highly dense, and due to the high node density, nodes interfere with each other's transmission. This increases packet collision and therefore the congestion in the network. So, a routing scheme should select a congestion-free, longer-lasting route and it should proactively switch to a new route in order to prevent the packet drop. In our proposed scheme, we use breadth first search algorithm to list all the candidate routes between a source and destination pair. For each candidate route, its route cost is computed using this formula. This is normalized hop count, this is normalized route lifetime, this is normalized buffer occupancy. Hop count represents the route length, and we want a route with lower hop count. Route lifetime represents how long the route will last, and we want a route with longer lifetime. Buffer occupancy is the number of packets an intermediate node has in its queue. So high buffer occupancy leads to high queuing delay, which reduces the flow throughput. So we want a route with low buffer occupancy. Link capacity is the maximum number of packets that a node can service per second, and it is a function of channel capacity, packet size, channel utilization factor, and link quality. Overall, we want a route with a low route cost. In this slide, the performance comparison in terms of PDR, which is packet delivery ratio, is shown between OLSR and our proposed scheme. We have used 30 fixed wing UAVs, which are moving at a speed of 20 meters per second in an 8 by 8 kilometer square area. The data is generated for 75 seconds, and we have tried for 10 different network scenarios. So here our scheme for 4 different weight combinations are shown, and when the weights are 1/3 for each routing metric, the PDR performance is the best. In fact, it is almost 20% more than the standard OLSR. However, the one weight combination does not cover all the different network scenarios. For example, when we do not consider buffer occupancy, this scheme gives the best PDR. Similarly, when we do not consider the route lifetime, this scheme gives the best PDR. So we observe that the one weight combination cannot be used for all the network situations. The importance of a metric depends on several factors, including network topology, TTL constraint, and the number of flows. Moreover, it varies with time. This makes the problem very difficult because we cannot have one weight combination which can be used for all the different network scenarios. And since it is evolving with time, can we actually use the weight combination? So therefore, instead of using weights for route selection, we compare different routes based on their route qualities. And then the route with the best quality is selected. For this, we trained a logistic regression model for binary classification, which compares a pair of routes based on their quality. Here, high PDR corresponds to high route quality. Routing metrics, hop count, route lifetime, and buffer occupancy of both routes are fed as input features. Right now, I'm in the process of generating more samples, but with around 1200 samples, the accuracy of logistic regression is much higher than the heuristic model which I showed in the last slide. Here, the accuracy is basically the ability to compare different routes successfully based on the PDR. Hopefully, with more samples, this accuracy will go up and we will be able to improve the PDR performance. Thank you.